Hello statistics students, my name is Jami Emigh, and this video starts our discussion on 8.2, testing a claim about a proportion. The program we're using is the same one we used in section 8.1. It's called Proportion Stats. So let's try it again with an example. A poll of 1,000 adult Americans revealed that 577 of those surveyed prefer the Democratic candidate for the presidency. At the 0.10 level of significance, test the claim that more than 55% of all voters prefer the Democrat. Use the critical value method. Okay, step 1, we set up our null and alternative hypothesis. Notice that the null is always equal to the 55% or 0.55, and the alternative hypothesis switches to greater than, less than, or does not equal based on the wording in the claim. Well, the wording in our claim was more than. That's why we use the greater than sign. That symbol right there leads us to our next step in which tail to cut off on our graph. So with the greater than symbol, we use a right-tailed test. So our graph looks like this. That cut right there, separating the rejection and the failed to rejection region. Know that it's on the right side of the bell-shaped curve. And that cut right there is at the critical value. So we're going to use StatCrunch to figure out what that value is right there. And then we'll see if the test stat lies in this blue region, making our decision fail to reject, or in this red region, making our decision reject. All right, let's open StatCrunch and figure out those two numbers. Critical value here, test stat here or here, significance level that we don't get from StatCrunch. That was given to us in the question. It's right here. It's not the default, notice. Default would be 0.05. All right, let's run this through StatCrunch. All right, we'll find that program under the Stat menu, Proportions, One Sample with Summary. We had X 577, N 1000. This defaults to 50-50. We have to change ours to 5.05, just according to the directions or the wording in the claim. This also changes based on the wording of the claim. This program is great, how it keeps these two numbers the same for us. It won't allow you to change this one because they have to be the same. That's great. The program helps us avoid that small mistake, potential small mistake. We're going to need the critical value, so we'll click that. And our significance level for this question is 1.1. Compute. There's the p-value, but we're not requested to use that one. We're requested to use the critical value method, so we're going to use these two numbers right here. The first one here, well, first, it goes p-value, then the critical value, if you're reading from right to left. The critical value right there, that goes where the cut was made. And then the test stat, we'll see where that lies. Okay, let's write that in our notes. Okay, we found that the critical value was 1.28, and we put that right here on our graph. We found that the test stat was 1.72, so where would that be on this number line? Negatives are over here, zeros here, 1.28 is here, so 1.72 will be over here in the rejection region. Once that's done, everything from here is basically just a script for us. We know that that is in the rejection region, so the script goes like this. Reject the null hypothesis. There is sufficient evidence to support the claim that more than 55% of all voters prefer the Democrat. Had the 1.72, had the test statistic been in this green failed to reject region, then the script would have changed. The script would have been failed to reject the null hypothesis, and then there is not sufficient evidence. So it really is just about where did that test stat fall. Critical value sets the bar, and then based on the study, did the test statistic fall here or here. Once you figure that out, though, you just have to know how to write the script from there. All right, let's try another one. A National Cybersecurity Alliance reports that 96% of all computers have an antivirus program. In a random sample of 4,000 computers, it was found that 380 of them have antivirus software program. Test the claim that the percentage of computers with an antivirus program is less than 96%. And this time they want us to use the p-value method. Okay, step 1, set up our null and alternative hypothesis. Notice this time that we're using the less than symbol. So that comes from right here, less than 96%. And that would, if we were to draw a graph right now, it would tell us to make a left-tailed test, but they're requesting the p-value method, so no graph necessary. So what we need to do now is go to StatCrunch. We need to find that p-value so that we can compare it to the significance level, which, as I'm looking up here, it doesn't say what the significance level is supposed to be. If it's not stated, that means that it would be the default, which is alpha equals 0.05. Okay, so we just need the p-value. We'll compare it to alpha, and then the script takes its place from there. All right, back in StatCrunch, same program as last time, so I can just go to Options, Edit, change X into, it was 380, N was 400. The claim was about 96%, and it was saying that less than 96%. Click on Show Critical Value, significance level back to the default, and then we hit Compute. This time, we're only interested in this one number right here, the p-value. If the program asks you, or if you're asked, what's the critical value? It's right here, negative 1.645, and the test stats right here, negative 1.02. But as far as the method we were requested to use is called the p-value, so we just need this one, 0.1537. All right, let's take that back to our notes and compare it to alpha. Okay, that p-value was 0.1537, which is larger than our significance level of 0.05. Sometimes this rhyme is helpful. P is high, the null will fly. If something will fly, that means we don't reject it. We say that'll fly. So we say fail to reject the null hypothesis. Whenever the decision is fail to reject, the conclusion is there is not sufficient evidence. Fail to reject goes hand in hand with is not. If you look one example back, you'll see that the decision was reject, and we said there is. That's because those go hand in hand. Reject. If your decision is to reject the null hypothesis, then you state your conclusion with there is significant evidence to support the claim. So these go hand in hand. Decision, how you start your conclusion. These go hand in hand. Decision, how we state our conclusion. One thing that always helped me is reject and is. Those ones are less words than over here. Fail to reject and is not. The only other word that could potentially change would be this one right here. And you would think like maybe that has something to do with the decision, but it doesn't at all. The only time this would ever change is if the claim was a special case where it contained equality. If the claim said like greater than or equal to, less than or equal to, or equal to. In these special cases, we would have to use their complement, and therefore we would have to use the complement of this one word right here, support. We'd change it to reject. But that's it. That's the only other word that could possibly change. Is and is not, And then this could change if it were a special case. Okay, let's try another one. Ooh. Not another one yet. First, 8.3. We're going to test a claim about a mean. All right, we know in this class that if we're doing anything that has to do with a mean, we might have to use the student t distribution instead of the normal distribution. So here, same situation. If the claim is about a mean, we're going to have to decide which distribution to use. And it always comes down to sigma. If sigma is unknown, we'll use t. If sigma is known, we'll use z. Same thing here. This is just if we're given the data instead of the summary. If sigma is unknown, we'll use t. If sigma is known, we'll use z. So these are the same. The difference in these two cells is if you're given a summary of the stats versus if you're given the data. Okay, from there, the input screen will let us know what it needs, and we'll hit compute. Let's try one. Oh, we got data this time. See this here? This is data. It's not the summary of the data. Okay, listed are the measured radiation emissions for a sample of cell phones. Use a 0.05 level of significance. That's alpha. To test the claim that cell phones have a mean radiation level, there's that word, mean. So we're going to have to decide student t or normal distribution. So z or t, because the claim's about a mean. Mean radiation level less than 1.00 watts per kilogram. And they want us to use the critical value method. All right, let's set it up. Null and alternative hypothesis. Notice that we're not using p because that was for proportions. We're using mu, that's the population parameter for means. Null hypothesis is always equal, and the wording in the claim led us to the less than sign. All right, critical value method means that we need a graph. The less than means that we're going to run a left-tailed test. 0 is here. Significance level is here in the tail. And for this method, we're going to find this number here called the critical value, and then we'll see if the test stat is in this region or this region based on the critical value. All right, let's find those. We've got our data in variable 1 column. Null was equal to 1.00 watts per kilogram, and alternative was less than that. Click show critical value, significance level, and we can hit compute. They requested that we use the critical value method, so we'll be using the negative 1.81 and the negative 0.48. Let's put that in our note. Our critical value was negative 1.81. That goes right here, separating the rejection region. The test stat was negative 0.48. That would be in the fail to reject region. Remember, positives are here, 0, negative. It's lower than, it's closer to 0 than negative 1.81. So it'd be right about here. Once we figure out what region that's in, to fail to reject, everything is scripted. We would say that we fail to reject the null hypothesis, and then we would conclude that there is not sufficient evidence to support the claim that cell phones have a mean radiation level less than 1. All right, another example. Test the claim that an adult population of one town has a mean annual salary of $30,000. A sample of 50 people had a mean of 28,298. Knowing that the population standard deviation sigma is 10,200, use a significance level alpha of 0.10 and the p-value method to test our claim. Okay, So let's make some notes before we set up our null and alternative hypothesis. Claim is about a mean, so we'll be using mu. It says annual salary of 30,000. That would be an equal sign. So this one here is a special case. In our alternative hypothesis, we can't use an equal sign because we use that in the null. So we're going to have to use the complement of that, which is the does not equal sign. All right, what else? We have a sample of 50, so that's n. They had a mean, so this is x bar, of 28,298. Knowing that the population standard deviation, oh, this is huge. This right here, you guys, this knowledge of sigma, the population standard deviation, tells us that we can still use the normal distribution. So we'll be using z-stat. And they want the p-value method from us. So we'll need to compare whatever we get for our p-value method to alpha 0.10, which is not the default. Remember, if any study isn't using the default, they need to say that in their conclusion. All right, let's set it up. Null hypothesis, mu equals 30,000. Alternative, mu does not equal 30,000. We need to run StatCrunch now. All right, we'll find that program here. One sample with summary. The sample mean was 28,298. The sample standard deviation was $10,200. That was, the mean came from a sample size of 50. We're comparing or testing their claim about $30,000 being the annual salary. This looks good. One last thing. All right, I think we're set up. That's x bar, that's sigma, that's lowercase n. This looks good, and compute. So we need the p-value for this method. It's right there, 0.238. Okay, we'll take that p-value, 0.238, and compare it to significance level, 0.10. P-value is greater than that, so you can use the rhyme if you want. P is high, the null will fly. So we fail to reject the null hypothesis. Now careful when we write our conclusion. We know that fail to reject always goes hand in hand with there is not sufficient evidence. But we have one additional change to the script. It's this word right here. We normally just use evidence to support the claim, but here we use reject the claim. This word has nothing to do with what our decision was. It has to do with this was a special case. That's the only reason that word needs to change as well. So just look out for it. The special case is when your claim is about equals, less than or equal to, greater than or equal to. If the original claim contains any of these, then we have to use a special case, and this word at the very end changes to reject. Section 8.4, still hypothesis testing. Just this time it's going to be on claims about standard deviations or variances. Let's see here for our StatCrunch notes. Given a summary of the stats versus given the data. Okay, given a summary, we'll open the program called variance stats, input what it needs from us, and run it. Given the data, it's the same program. It's called variance stats. It's just the program needs different things from us. It needs to know basically which column the data is in, and we'll run it. Let's try one. Listed are the heights in inches for a simple random sample of supermodels. Use a 0.01 significance level to test the claim that supermodels have heights with a standard deviation, and therefore a variance, less than the general population. which is 2.6 inches. Use the critical value method. Okay, some notes before we start. This, significance level, not going to need that much because we're asked for the critical value method. We're definitely given the data here. Know that program is going to ask us for sigma. That's the standard deviation here. How many of these do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from the 10 data values. Okay. Let's just find the wording of the claim. Test the claim that supermodels have heights with a standard deviation less than the general population. So we're going to use the less than sign based on this right here. And this claim is about standard deviations, which relates to variance. All right, let's set it up. Null hypothesis is that sigma equals the 2.6 inches. And alternative hypothesis is their claim that sigma is less than that. So less variance in the heights of supermodels compared to the whole population. All right, critical value method means that we need a graph. This is a less than claim. Our alternative hypothesis, we're using a left-tailed test. Notice that this is just quadrant 1. 0 is over here. That is because standard deviation and variance don't fit in the normal or the student t distribution. They fit right here in the chi-squared distribution, which takes place all in quadrant 1. It's not symmetric, and we know that it changes based on the sample size. Let's run this through StatCrunch to figure out the critical value and the test stat. All right, in StatCrunch, we'll go to the stat variance stats, one sample. We were given the data. Data's there in column var 1. Okay, got an issue right here. Check this out. Null and alternative hypothesis. It's for sigma squared. That's because the program called variance stats is set up that way. We were given the population standard deviation, not the population variance, but that's okay. We know we can calculate it. We just have to take what was normally what we had. We had 2.6. We have to change that. We have to do 2.6 times 2.6. So I'm just going to take my calculator off to the side and just do 2.6 times 2.6. So it's going to be 6.76. That's just required because the program variance stats is about variances. All right, they claimed that it was less than the population, and I believe this was a 10, and compute. P-value is 0.0003. This right here would be the critical value, 4.168159, and here we have the test stat, 0.859. All right, let's put that in our notes. Okay, our critical value was 2.088. So left-tailed test, we're going to cut that off about here. Critical value 2.088. And the test stat was 0.852. That's in this rejection region, maybe right about here. So it's in the rejection region. So that makes our decision reject the null hypothesis. And our script goes, there is sufficient evidence to support the claim that supermodels have heights with a standard deviation less than 2.6 inches, and therefore their heights have less variation than the general population. All right, one more. The standard deviation of math scores at one high school is 16.1. A teacher claims that the standard deviation of boys' scores is greater than 16.1. A simple random sample of 30 boys results in scores with a standard deviation of 16.3. Use a 0.1 significance level to test the teacher's claim. All right, setting up our null and alternative hypothesis. We have sigma is equal to 16.1. This wasn't about heights. This one was about points. Yeah, math score, 16.1 points. And the teacher claims that for the population of boy students, the standard deviation is greater than the 16.1 points. All right. This would be a right-tailed test. So we're going to cut off the right tail. So we're going to use StatCrunch to figure out critical value would go here. We could figure out where the test stat lies. It doesn't say which method we have to use, so we could also just find the significance level here, compare that to the p-value. Either method works. You'll get the same result regardless of the method you choose. All right, let's load this. All right, when selecting our program, notice that we have proportion stats. We've got t-stats and z-stats. You have to select one of those when we are testing a claim about a mean. We've got variance stats, but this particular claim is about a standard deviation. There's no standalone program for standard deviation, but that's okay. We can use this program here, variance stats, one sample based on a summary. What this program wants from us on the input screen is sample variance, sample size, and notice the null and alternative hypothesis are set up for sigma squared. So we were given the information about the standard deviation, but we also know that if we square the standard deviation, we'll have the variance. So when you go to type in your sample variance, just taking my calculator out. All right, that was a standard deviation sample was 16.3, but the input screen needs the sample variance, so we need to square that. So we need to multiply it by another 16.3. Program won't do it for us, so just use your calculator. 16.3 squared gets us 265.69. Sample size, this teacher sampled 30, and null hypothesis, tempting to put 16.1, but that was our null hypothesis for sigma. This is sigma squared, so we have to take 16.1 and multiply it by itself. Again, program won't do it for us, so take your calculator, do 16.1 squared, you should get 259.21. Changing the alternative hypothesis symbol, the teacher claimed that the standard deviation was greater for the boy students than the girls. Show critical value and change our significance level and compute. Output screen, we've got our p-value here. Critical chi-squared value 39.09. And this right here, it says chi-square stat. That is the test statistic, 29.72. All right, let's see what that looks like in our notes. Okay, we had a critical value of 39.09. That goes right here, separating the failed to reject region from the rejection region. And we had a test stat of 29.72. That would be somewhere between 0 and our critical value. Putting our test stat in the failed to reject region, making our decision. Failed to reject the null hypothesis. After a decision is made, we just get to read the script from there. That would be there is not sufficient evidence to support the claim that the standard deviation of boys' scores is greater than 16.1. All right, Last thing I want to note for you guys is the program will sometimes, instead of saying there is not sufficient, it might say there is insufficient. Nothing changes in the process, just a different way to say not sufficient is insufficient. So just heads up for that. Don't change anything you've done. Just make sure you understand that there is not sufficient evidence is the same thing as there is insufficient evidence. All right, don't worry, you'll do great. My name is Jamie. Amy, thank you for being here, and I will see you next.